Hello everyone, welcome to Diksha Karnataka YouTube channel, and in the part of free ABHYAS test series, today I am going to give you the solution of physics part test 3. Now if you have registered for ABHYAS, you are going to get 4 free part tests. So this paper is one of the 4 free part tests, and today I am going to discuss the solutions of the questions, and if you have any doubts you can clear that. Obviously, how to access ABHYAS test series, the link is given in the description section of this video. You can go and click there and you can register yourself and you can get access to 4 free part tests. Okay, if you want to access the entire ABHYAS test series, you have to pay only 999 to get the unlimited access of the entire test series. Okay, so out of the 4 free part tests, we decided, okay, why not discuss the solutions of those questions in YouTube. So part of that series I am going to discuss physics paper 3, part test 3. Okay, the syllabus of this paper is obviously electric charges and field, electrostatic potential and capacitance, current, electricity, moving charges and magnetism, magnetism and matter, electromagnetic induction, alternating current and electromagnetic waves. So this is the syllabus of the first part test. So as you can see, all the chapters are super important. So let me discuss the solution of this part test. Okay, so first, obviously, question number 1, a 4-volt battery, and if you want to download or get access to the ABHYAS test series, obviously what you have to do, you are obviously you know the rule, join the WhatsApp and obviously if you register yourself for ABHYAS, you will get this 4-part test. Okay, the questions will come, and today I am going to discuss the solutions. A 4-volt battery of internal resistance 1 ohm sends a current to a 3 ohm resistor. The terminal potential difference is. So very simple, just use the formula. We are not going to do any difficult mathematics. Just use the formula ER divided by R plus small r and apply the values given in the question. You can directly get the answer as 3 volt. Okay, now let's move on to question number 2. Question number 2, the magnetic properties of a magnet is lost at its Curie point. Okay, magnetic property is lost at Curie point. Even though the detailed mathematical calculation and explanation is not there, but it is mentioned that below Curie point a ferromagnetic material behaves as a paramagnetic material, and below Curie point paramagnetic becomes ferromagnetic. Okay, Curie point is the transition temperature. The waves suitable for transmission of radio signals are infrared, waves longer than infrared, waves shorter than infrared, X-rays. Okay, so to transmit radio signal means FM radio, okay, or AM radio, the radio that we hear in our day-to-day life. To transmit radio signals, we generally need to have a longer wavelength. So that means waves which are longer than infrared. Okay, waves that are longer than infrared we need to have. Okay, so exactly the same is given in the answer of this question. Question number 4, resistance of a conductor is 5 ohm at 50 degrees Celsius and 6 ohm at 100 degrees Celsius. The resistance at 0 degree. So you can answer this question 2 ways. One is mathematically as given in the question, and you can calculate the resistance to be 4 ohm. There is a logical reasoning for this question as well. So if you see that from 50 to 100, the resistance increases by 1. Okay, so if you see that from 50 to 100, the resistance increases from 5 to 6. Okay, and the increase in temperature is how much? 50 to 100. That means 50 degrees. 50 degree increase means resistance increases by 1. So now final temperature is 0 degree Celsius. So 0 and 50, what is the difference between 0 and 50? Again 50 degree, but it is obviously in the negative side because temperature is decreasing in this case. So resistance must decrease by the same amount. That is, here resistance was increasing, so it was plus 1. Now in this case, because resistance temperature is decreasing, resistance must decrease by 1, so it will be 4 ohm. Okay, that is a logical answer to the same question. You don't need to do the mathematics. If you are not sure, you can answer it logically as well. If you want to use mathematics, you have to first calculate the coefficient of resistivity, temperature coefficient of resistivity, and then you have to use the formula R naught 1 plus alpha T, and then you can calculate R naught. Okay, that is the mathematical answer. So there is always a shortcut method, sometimes there is a mathematical method. Some cases mathematical methods are more suitable, some cases shortcut methods are applicable. Logic is more important than, to save time, logic is more important. So this question can be answered logically as well. As the charge on the capacitor increases, its capacity remains same. Okay, as the charge increases, does not matter charge increases or potential increases. Okay, we know that it is a proportionality constant. Capacitance is a proportionality constant, so it does not change with charge or voltage, so it should remain the same. Okay, now next question. Identify the wrong statement. So be careful, this kind of question I always mention, identify the wrong statement. 3 of them are correct, 1 is wrong. Coulomb's law correctly describes the electric force that binds the electrons of an atom of its nucleus. So this is a wrong statement. Coulomb's law does not give you the idea about how the electrons are binding into the nucleus. Okay, binds the proton and my mistake. Electrons, how electrons are bound to the nucleus is correctly explained. Okay, electrons are basically attracted toward the positively charged nucleus, and that provides the required centripetal force. So this is a correct explanation. This one is correct. Okay, binds the protons and neutrons in the nucleus of the atom. This is not explained by Coulomb's law. This is explained by the atomic theory, right? Atomic property of nuclear force. So this is the wrong statement. Binds atoms together to form molecules. This is correct. Positive, negative, they attract, form nucleus from molecules. That is correct. Binds atoms and molecules to form solids. That is also correct. Okay. Positive, negative, they attract, they form bonds. That is because of Coulomb's law. So this is also correct explanation. But protons and neutrons, how they are attracted towards each other, can be explained using only nuclear force, not by Coulomb's law. So very interesting, intelligent question. Okay, straightforward, direct question, but if you think about it slightly in detail, you might be confused. So make sure you read such questions carefully before answering. Okay, this kind of questions are, by the way, common in KCET. Questions which are new, you may not have seen those questions. Obviously, the questions you have not seen, and they will try to confuse you many ways. So you have to come out of that confusion. Okay, and for more practice, obviously, what you can do, you can click on the link given in the description and register for ABHYAS Test Series. A metallic pipe carries a direct current. Correct statement about the existence of magnetic field is: it exists outside only, it exists inside only, it exists both inside and outside, it exists neither inside nor outside. So it's a pipe. Metallic pipe means hollow from inside, right? Metallic pipe means hollow from inside, so no current is being passed inside. All the currents are being passed only through the surface. That means what? That if you apply Ampere's circuital law, inside the magnetic field will be 0, magnetic field will be outside only. So we can say that it exists outside only. Okay, so magnetic field does not exist inside because magnetic field inside is 0. Okay, all the currents are being passed through the surface of the pipe. That means inside no current, and no current means it will be 0. Next question. If an electric dipole is placed in an uniform electric field, it experiences only torque. Okay, electric dipole in an uniform electric field, it experiences torque only. Assertion and reason based question, these are also common in KCET. Microwaves can be absorbed by the surface of the earth. Okay, reason: microwaves cannot be reflected by ionosphere. Let's see, both statements, and assertion type only, and second statement is not a reasoning statement. Both statements are correct, by the way. Infrared radiations can be infrared and all the wavelengths which are slightly higher in wavelength, they generally get emitted from the surface. Okay, so microwaves can be absorbed by the surface of the earth. Surface of the earth can absorb all type of radiation, gamma rays, X rays, UV rays, all type of radiation can be absorbed by our surface. Okay, now we know that many of them are actually absorbed by ozone layer, so that does not come down to harm us. But again, if it is left open, obviously they will absorb all type of radiation, including microwave. There is no specialty about microwave. So this is a correct statement. And generally the ionosphere only can reflect the wavelength which are shorter. Okay, shorter wavelengths generally get reflected, longer wavelengths they do not get interfere with the ionosphere, so they cannot be reflected by ionosphere. So this is also correct statement. Both are statement type question. Both are statements. They generally do not have any reason behind these two. So both statements are correct, but reason is not the correct explanation. So if there is no logical connection between the two, okay, how can you say that it's the correct explanation? So you have to make sure that you answer them correctly. It's very tricky question. Now question number 10, electric potential at any point V is minus 5x plus 3y plus 15 square root of 15z, then the magnitude of the electric field is. Slightly tricky, longer question. Okay, this kind of questions are also might come in your KCET. So make sure how to do that. Don't worry about these symbols. So Ex basically is given by the electric field, or x component of electric field is given by minus dv dx, okay, with y and z constant. Okay, this is the meaning of this symbol. Okay, so this is called partial derivative. Those who know partial derivative, this is called partial derivatives. So partial derivative means you are simply differentiating, but y and z are constant. So you are differentiating only the x term. Yz remains constant, so minus 5x, and there is a negative sign over here, so minus 5x. What is the differentiation of 5x? ddx of 5x, 5, right? So minus minus plus, so ddx of 5x is 5, so you get 5 over here. Similarly, ddy of 3y, you get minus 3, and ddz of square root of z, you get minus square root of 15. So you get all three components. Once you calculate all three components, you just need to take the square of them and add them, and finally take the square root of them. You get 7 unit as your answer. So option D is correct answer for this question. Now let's move on to the next question. A and B are two infinitely long straight parallel conductor. C is another straight conductor of length 1 meter kept parallel to A and B as shown in the figure. Then the force experienced by C. So here if you see that there are 3 wires, okay, A, B and C. Okay, I hope it is clear. A, B and C, 3 wires are there. A is carrying 2 ampere, C is carrying 3 ampere, B is carrying 4 ampere. Now first of all, let us understand the direction. Okay, so these are all parallel currents, so they will attract each other. Okay, these two are also parallel, so they will also attract each other. So basically you need to find the force between these 2 wire and these 2 wire, and subtract larger minus smaller. Okay, that should be the process. So you have to calculate the individual forces. So if you calculate individual forces, force due to conductor A is 2.4 into 10 to the power of minus 5, force on B is 3 into 10 to the power of minus 5, and then as you can see, this is bigger, this is smaller. So difference of 3 minus 2.4, that is 0.6 into 10 to the power of minus 5 Newton. So answer is B. Okay, towards B, the force is also, you can calculate, it is towards B. Okay, and obviously the answer will be B. Next question. The dipole moment of a current loop is independent of current in the loop, number of turns, area of the loop, magnetic field in which it is situated. Okay, so dipole moment of the current loop is given by NIA, so obviously it does not depend on magnetic field in which it is situated. So option D is correct answer. Okay, so National Investigative Agency, that is the dipole moment formula. So obviously it depends on number of turns. Now this is a very interesting question. in the loop shown, magnetic induction at the point O. So if you see that there are one current carrying loop is coming like this, then there is a loop like this, okay, it is being carried like this, then there is a cut over here, then this is coming like this, and then it is coming like this, and then it is coming back. Now here, this arm, and this arm, they will not have any effect. Only effect that we need to calculate is this quarter and this quarter. Why I am saying quarter? Quarter means if you consider a complete circle, this is only 1 quarter, right? So if you construct a complete circle, it will be 1 quarter. If you construct another circle, it will be another quarter. Okay, so if you calculate the quarters and add them, you will get the total magnetic field. Okay, so we know that magnetic field at the center of a complete circle is given by mu naught I by 2r. Here we have 1/4 of the circle, that is quarter. Okay, so 1/4 of first circle B1 you can calculate, and B2 you can calculate. Just what is left, you add them. Radiuses are different, so it will be mu naught I by 8 R1 plus R2 divided by R1 R2. So correct answer is option A. Okay, mathematics, obviously you need to do the mathematics in some question. Another assertion and reason based question: a charged particle free to move in an electric field always moves along the electric field line. So charged particle, first of all, free to move in an electric field line, not always move in along the electric field line. It can move opposite direction also. Secondly, if the charged particle is already in motion, because it is not mentioned particle is static or not. Okay, even if it is static, you might say that okay, it is moving either in the direction or in the opposite direction. You might say okay, this is moving along. But if the particle free to move means it can already be in motion. So if the particle is already in motion, okay, in that case the charged particle can move in any direction, but there will be an acceleration. Direction of acceleration will be either in the direction of electric field if it is positive. If it is negative, there will be an acceleration in the direction opposite to that of the electric field. So will move is incorrect. Accelerate in the direction or opposite direction is correct. Okay, so you cannot say that it will move. It might accelerate in the direction of electric field or opposite to the electric field based on the charge. Okay, the electric field lines diverge from negative charge and converge to at a positive charge. First of all, this statement is completely wrong. So both statements are wrong. Okay, and obviously this is nothing to related with this statement. This is completely separate statement, and this statement is wrong. This statement is also wrong. Okay, so both statements are false. So option D is correct. So if you see that the explanation is given in for this question as well. Okay, next. If an LCR series circuit connected to an AC source, then the resonance, the voltage across R equals the voltage. Okay, so remember that at resonance, voltage across R is exactly equal to the applied voltage. Okay, combination of L and C is 0, but voltage across R is exactly applied voltage. So option B is correct. Now question number 16, a positively charged particle is released from rest in a region uniform electric field. The particle will move. So positively charged particle is released. So it is released from the rest. Okay, in a region of uniform electric field, it's a positively charged, so it will start moving with an acceleration. Why? Because a charged particle will experience a force F given by Q into E, and from there we can calculate. So M into A must be equals to F, and we can calculate A is equal to F by M, or Q into E by M. Right, so the charged particle will accelerate. Okay, so it will move with an constant acceleration. It will move with a constant acceleration, not variable acceleration, because obviously electric field is constant, uniform. So uniform electric field means E is constant, so it will move with a constant acceleration. Okay, next, a circuit based question. The voltmeter connected in the circuit shows a reading of 5 volt. Resistance of the voltmeter is. So here you are shown a circuit, so 100 ohm, 50 ohm, and 10 volts. So you have to calculate the individual total current in the circuit, and based on the current you have to measure the actual voltage across this 100 ohm. Okay, and so you have to, voltmeter is 5 volt, that is volt across 100 ohm is 5 volt. The series combination is possible if effective resistance of the portion is 50 ohm, that is resistance of the voltmeter is 100 ohm. Okay, so first of all you calculate the voltage across the voltmeter is given, that is 5 volt. Okay, so that means the voltage across this 100 ohm is 5 volt. Now how to solve it quickly? So the actual given voltage is 10 volt. Given voltage is 10 volt. Now if voltage across this one is 5, then what is the voltage across this one? From conservation of energy, if this is 10 volt, 5 across this, that means this will also have 5 volt. Very simple, 10 minus 5 equals to 5. Now both of them have same voltage. Both of them have same voltage. How it is possible? Only if both resistances are equal. Okay, both resistances are equal, then only you will have a situation where this is V by 2, this is also V by 2. If both resistances are equal, that means if this is 50 volt, this combination will also have a 50 ohm resistance. So combination of this one will have a 50 ohm resistance, right? Then only 5 volt separation is possible. So that means if this resistance is R, you just need to say that, okay, 100 R divided by 100 plus R must be equals to 50, and on simplifying you will get R equals to 100. One more way is to say that, okay, so this combination has half of the total resistance 100, that means this one, both of them should have same resistances. So 100 and 100 combine in parallel, the total resistance will be 50. That is another logic, right? Now let's move on to the next question. A wire of resistance 1 ohm is elongated by 10%. The resistance of the elongated wire is. So you calculate the new length, and from the formula you can calculate the new. Now when you are elongating the length, obviously you are changing the area as well. Correspondingly you can calculate, it will be 1.21 ohm. Now there is a shortcut method, always remember. So if the original resistance is given 1 ohm, length is elongated by 10%. Remember, when you are elongating or stretching a wire, its area decreases. So you cannot simply calculate by only based on length, you also have to calculate the area. Now what is the shortcut method? So length is elongated by 10%. Okay, so if initial length was say L, the new length will be 1.1 L, right? So now this is the factor that you need to consider. If length changes by a factor of X, then the new resistance is given by the factor square into old resistance. This is the shortcut formula. Okay, if you can calculate, length is increased by say 20%. 20% increase means new length will be 1.2 times the original length, right? So if you know that factor, you just need to take a square of that and multiply the old resistance. So 1.1 square means 11 square, that is 121 and 2 decimal. So 1.21, and the old resistance is 1, so this will be 1.21 ohm. This is the shortcut formula, shortcut method to solve such questions. Okay, don't be afraid. You should also learn and you should also be able to solve such questions quickly, or otherwise original methodical process is always there. In an AC circuit, capacitive reactance equals to inductive reactance. The phase difference between the current and voltage will be 0. So capacitive reactance equals to inductive reactance means the circuit is in resonance. That means the phase difference should be 0. Current and voltage should be in phase. Okay. Two capacitors of capacitance 2 microfarad, 6 microfarad are in series across 10 volt source. The charge on the capacitors will be, so simply use the equivalent capacitance rules. Once you know the equivalent capacitance, the voltage is given in the question, just apply the equivalent capacitance and multiply, you will get the charge very easily, not super difficult. You will get 15 microcoulomb. Okay, easy question, straightforward formula based question. Remember, if combination of capacitance etc. is coming, always try to find the equivalent capacitance. Next question, the difference in the effective capacitance of the similar capacitors when joined in series and parallel is 6 microfarad. What is the capacitance of each capacitor? Okay, so when you connect two similar capacitors in parallel, okay, their capacitance is 2C. Cp means parallel is 2C and C series is C by 2. So Cp minus Cs is given as 6 microfarad. So you just simplify them and you will get the answer as 4 microfarad each. Okay, not difficult. In the circuit given below, the ammeter and the voltmeter are ideal measuring devices. The reading of the voltmeter is. So here we have an ideal measuring devices. That means what? Ideal means the resistance of ammeter is 0 and resistance of voltmeter is infinity. Okay, so how can you calculate the voltage? Now here ideal ammeter has 0 resistance, so no matter whatever current passes through this, okay, what voltage drop you are going to get across this? Voltage drop across the ammeter will be given by current into resistance, which is 0, that is 0. So this voltmeter will give you a reading 0. Do not get confused by the total voltage of the circuit. Okay, you will only measuring the voltage drop across the ammeter. If the ammeter is ideal, you will not get any reading here. Okay, this is a very common full level questions of KCET. Okay, so be very careful, because you are measuring the voltage across the ammeter. Ammeter has 0 resistance, there will be no voltage drop, and hence the voltmeter will show 0 resistance. Okay, now next, question number 23, the magnetic flux linked with the coil varies with the time as phi equals to 3t square plus 4t plus 9. Obviously, what you have to do? Simply just differentiate it, and from there you will have to calculate the time is given here 2 seconds. Put the time t equals to 2 seconds and you calculate the voltage. Very easy question. Okay, differentiation, simple differentiation. Now next, a spherical conductor of radius 2 centimeter is uniformly charged with 3 nanocoulomb. What is the electric field at a distance of 3 centimeter from the center of the sphere? Okay, so center of the sphere, how to calculate that? You just simply charge is given, radius is given at a point 3 centimeter from the sphere. It will be simply like a point charge. You can easily calculate 1 by 4 pi epsilon naught q by r square. Put the values, you will get 3 into 10 to the power of 4 volt. Easy question, nothing to worry of. Okay, electric field outside a sphere. Charge is given, total charge is given, distance is given. Simple formula. The core of a transformer is laminated to reduce the eddy current loss. Okay, remember there are 4 losses, main 4 losses in a transformer. Eddy current loss is one of them, hysteresis loss, and then we have flux leakage loss, okay, and heating loss. Okay, now how to reduce the hysteresis loss? By using soft iron core. Okay, by using laminated core we reduce the eddy currents. To reduce the flux leakage, okay, what we use? We use concentric coring. Okay, core is one, they are winded one over another so that the flux leakage is minimum. Secondly, to reduce heat, we use low resistance material. Soft iron is generally considered slightly high resistance, but anyway you have to compromise on one quality over another. Okay, that's why in some smaller devices we use copper. Okay, in copper wire is used, obviously soft iron material and copper wire, to reduce the effect of heating. Okay, so these are the 4 major losses in a transformer. Next, in an ideal transformer, the voltage of the current in the primary are 200 volt, 2 ampere, and that in the secondary is 2000 volt and I ampere, the value of I. So power in an ideal transformer, power should be same. So 200 into 2 will be 2000 into I. So from there you can calculate the current to be 0.2 ampere. Okay, it will be simply 0.2 ampere. Two identical metal spheres with charge 2q and minus q are separated by a distance. Force between them is F. they are connected by a conducting wire, then removed. Force between them. Obviously, initially one of them had 2q charge, another one is minus q, so the force is given by F. So you can calculate the F simply by k q square, q1 q2 by r square. Okay, now when you connect them, what happens? The charge is redistributed. Okay, so total charge is now 2q minus q divided by 2. Okay, so this is the charge on each sphere. Q by 2 is the charge on each sphere. Now again apply Coulomb's law, calculate the force, and it will be coming out to be 1/8 of the original value. Okay, simple, not difficult. The current in a self-inductance L equals to 40 millihenry is to be increased uniformly from 1 ampere to 11 ampere in 4 millisecond. The EMF induced in the conductor. So obviously EMF induced in this case will be dl L di by dt. L is given, self-inductance is given. Okay, change in current means final current minus initial current, or you can take the larger minus smaller, you ignore the negative sign, obviously negative sign is not required. So bigger minus smaller is the change in current, time difference is given. So from there you can calculate the potential induced EMF is 100 volt. In the following network, potential at O. So this is the network. Okay, I think some part of the diagram is missing. Yes, so if you see here, A, B, C is given. A is at 8 volt, B is at 4 volt, C is at 2 volt. Okay, and the point potential at O. So current, you have to remember how to solve this question. You take the potential at O, VO suppose. Okay, potential at VO. Now apply Kirchhoff's law. What is the Kirchhoff's law that you have to apply? Suppose this voltage is VO. Now suppose if current through this branch is I. Okay, current through this branch is I1, current through this branch is I2. So obviously Kirchhoff's law says that I must be equals to I1 plus I2. Okay, now what is I? I is larger potential minus smaller potential divided by 2. That is Ohm's law. Difference in potential by resistance is the current. So you get 8 minus VO divided by 2. And what is I1? Now this is larger because current is moving from O towards B. So it must be VO minus 4 by the resistance 4 plus VO minus 2. So this voltage is given, these voltages are given. Okay, terminal voltages are given. So this voltage minus this voltage divided by resistance. Now you simplify this equation and you get the voltage at O as 4.8 volts. Simple, easy, not difficult. No rocket science. The value of magnetic field induced in the center of the coil if I is equal to 2 ampere, H is equal to 10 centimeter in the following figure. Now this is a very common question. Okay, we have seen a similar question in KCET as well. So here there are two components of magnetic field. One is due to the current carrying circular component, which is 3/4, by the way, not complete circle, and there is one component of this. So if you consider an infinitely long wire, okay, infinite long wire, it is only half of the infinity. Why half? Because this half is missing. Okay, this half is missing, that means only half of the wire. So if you if you put the values, you can get the from the straight wire you calculate the magnetic field, and for the circular area also you calculate the magnetic field, and then you add them to calculate the value as 1.214 into 10 to the power of minus 5 Tesla. If it is a calculation based question, I am not, obviously, as you can see, I am not doing the entire calculation. Obviously the answers are there. If it is a conceptual question where you need to know some concepts, I am explaining as much as possible. Obviously you should put your focus more on building concepts rather than just doing the mathematics. Mathematics you have to do, obviously there is no alternative to that, but mathematics you still have to do it. Okay, first of all try to understand the concept, how to solve, how to approach a question. Once you understand that, then mathematics will automatically come. Once you have understood the concept, just putting the values and calculating will automatically come towards you. Okay, but if you don't understand what formula to use, what concept to use, you will not be able to answer such questions. Okay. Now this question is actually based on a PYQ. So if you remember that PYQ, you just need to put the values inside that formula and you can answer it. In the following circuit, VC means potential across the capacitance, is given as 40 volt. VR and C are approximately. So you are also not only you have to calculate VR, you also have to calculate VC as well. Okay, total voltage is given 50. Now how to solve it? Obviously we know that VR square plus VC square root, only two of them are there, R and C. So VR square plus VC square root will give you the total voltage V, that is 50. Okay, using that you can calculate the VR. Okay, so V square equals to VR square plus VC square, and if you simplify you can calculate VR to be 30 volt. Now once you calculate VR, you can calculate the current in the circuit. How to calculate current? VR by R, okay, or VC by XC. Now XC is obviously not known, so if you know individually each component, voltage of each components, you can calculate the current by dividing the component voltage by the resistance, okay, or reactance. So you can calculate the current in the circuit is 0.5 ampere. Now you can calculate the current again, as I mentioned, VC by XC as well. That will also give you the same current, right? Remember, because all the components are connected in series, so if you calculate the current by VR by R, it is not always V by Z. Remember, this is also correct if you know the voltage across resistor. Most of you have made a mistake during your final board exam paper where V was given, Z was given. You are calculating resistance by this formula, which is wrong. Okay, only if you know VR, you can calculate current by this method. Okay, but if you do not know VR, if only V is known, current is given by V upon Z. Okay, V upon Z, this is the total voltage. But if you know the component voltage, then you can write current equals to VR by R. Clear? Doubt? Okay, most of you had this doubt in your during final board exam. Most of you are asking, sir, I did V by R, will that be correct? So V by R is not correct, VR by R is correct. Okay, there is a difference. This is the total voltage, this is total voltage, this is total impedance. This is the component voltage only across resistance. Okay, only across resistance is known, and that current is same as VC by XC. So if you know the individual component voltages, you can use these formulas. If you do not know the component voltages, you cannot use this formula. Now obviously VC is given in the question itself, okay, and current you have calculated. From there you can calculate XC. Now what is XC? XC is 2 pi FC. So 2 pi FC equals 1 by 2 pi FC is 80, and by simplifying you will get approximately 40 microfarad. Now if similar question comes in your exam, they will provide you the values such a way that you don't need to do a lot of mathematics. Okay, that is for sure. Here also you do not need to do a lot of mathematics, you can easily simplify it. Okay. Next, a charged particle with velocity 2 into 10 to the power of 3 meter per second passes undeflected through electric and magnetic field in mutually perpendicular direction. The magnetic field is 1.5 Tesla, the electric field intensity will be. Now that means when mutually electric field and magnetic field are perpendicular and the charged particle is passing undeviated, that means force acting on the charged particle due to the magnetic field and due to the electric field both has to be equal and opposite direction. So how to do that? You can do one more thing, that is from your velocity of a particle in an electromagnetic field. Okay, velocity of a particle in electromagnetic field, which is given by E upon B. That can also be used. This is a shortcut method in this particular case. Okay, you can use Q into E also. That will also be give you the same thing. Okay, if you are wondering, sir, can I use Lorentz formula? Yes, you can use Lorentz formula as well. Q into E is equal to QVB. Okay, Q cancels, so V equals to E upon B. Okay, you use this formula is more common in case of electromagnetic wave. You can use electromagnetic wave formula starting with this, or you can use Lorentz force calculation as well. Both are correct. So this is from Lorentz force. Electric force equals to magnetic force. So both has to be equal. So if a particle passing through undeviated, that means there is no net force acting on it. Okay, so no net force acting on it means the electric and magnetic field, electric and magnetic force must be equal and opposite, so they will cancel, and from there you can calculate the electric field to be 3 into 10 to the power of 3 Newton per Coulomb. In a region, the intensity of electric field is given by E equals to 2I cap plus 3j cap plus k cap in Newton per Coulomb, the electric flux through the surface. So surface area is given, electric field is given. What is electric flux? E dot ds. Okay, so here E into E dot s. Okay, just do the dot product, so it will be 20 Newton meters per meter square per Coulomb. So correct answer will be D. Easy question. Okay, nothing to worry about. Simple dot product. So this is why KCET is easy, considered to be easier than other competitive exams. A long solenoid with 80 turns per centimeter carries a current of 1 ampere. The magnetic energy stored per unit volume, very simple formula. Okay, calculate the magnetic field mu naught Ni, and magnetic energy stored is given by half B square by mu naught. This is a not super common formula, but this formula is there in your NCERT. Okay, so do remember this formula as well. So magnetic energy stored per unit volume is half B square by mu naught, and from there you can calculate the energy to be 3.2 pi joules per meter cube. Unit energy per volume, right? So joules per meter cube is the unit energy per unit volume. Potential difference across the resistance, capacitance and inductance are 80 volt, 40 volt and 100 volt respectively in an LCR circuit. The power factor of the circuit. Now how to calculate power factor? So here obviously power factor is R by Z. R is not given, neither R is given nor Z is given. So how to calculate that? So R can be replaced by VR. Why? So if you remember, what is VR? VR is actually, just a second, VR is nothing but I into R. Okay, and what is V? Total V? Total V is I into impedance Z. So VR by V will be R upon Z. So this is the power factor cos phi. Cos phi itself is the power factor. You do not need to calculate phi. Remember, power factor is cos phi, the complete term. Okay, not phi. Phi is phase angle. Okay, so from there you can calculate the power factor to be 0.8. It is not 1, and power factor maximum value is 1 at resonance. Okay, otherwise it will always be less than 1. A uniform wire 10 centimeter long is carrying a steady current. The potential drop across it is 10 volt. What is the electric field inside it? 0, 1 volt per meter, 10 volt per meter, 100 volt per meter. So E is equal to dV by dx. dV change in voltage is 10, distance is 0.1, so it will be 100 volt per meter. Correct answer option D. A charged particle experiences magnetic force in the presence of magnetic field. Which of the following statement is correct? Charged particle is experiencing magnetic force. That means the particle is moving and magnetic field is perpendicular to the velocity. Okay, the particle is moving and magnetic field is parallel to the velocity. So if the particle is moving parallel to the velocity, it will not experience any force. Now in perpendicular, it will experience a force in a particular direction that will give rise to centripetal force. Okay, particle is stationary. Stationary particle does not experience any force in a magnetic field. The particle is stationary and magnetic field is parallel. Obviously both cases are zero cases, so only in case number 1 it will experience force. Now remember, it will experience force as long as particle is moving and it is not parallel. So two cases, two condition has to be satisfied. It is moving, V is not 0, and B and V are not parallel. If they are parallel, force will be 0. If particle is stationary, V is 0, so the force will also be 0. Okay, now next, a step down transformer reduces the voltage of a transmission line from 2200 volt to 220 volt. The power delivered by it is 880 watt and its efficiency is 88%. This is not an ideal transformer. Ideal transformer has an efficiency of 100%, but it's a practical transformer, very good transformer. 88% efficiency is a very good transformer. Okay, the input current is, so first of all you have to calculate V1 by V2 equals to I2 by I1. This is for ideal case. Okay, now V2 into V1 is 88%, so from there you can calculate the power delivered, and taking the efficiency you can calculate this current to be 0.455 ampere. Okay, so first you calculate the ideal current. Okay, and using the ideal current, now you use the reverse engineering of efficiency, and you can calculate the current. Okay, you can solve it in another way also, no problem. If you are comfortable, you can use the other way also. This is the formula based approach. The amplitude of the sinusoidally oscillating electric field of a plane wave is 60 volt per meter. Then the amplitude of the magnetic field, remember for an electromagnetic wave in vacuum, the speed of light is given by E by B. Okay, so here E is given, C is already known, so you can calculate the magnetic field B. Very easy question. Next, two parallel plates are separated by 2 cm. If the potential difference between them is 20 volt, then the electric field between them. So obviously E is equal to V by D. V is given, distance is given, you can calculate the electric field. Easy question. An alternating voltage of frequency 50 Hz is fed to a circuit having resistance 628 ohm and inductance of 2 Henry. Phase angle between the current and the voltage. So XL is known, R is known. So what is the phase angle? Tan inverse of XL by R. Okay, X is 0. What is the phase angle? Tan inverse. So I already told you multiple times, phase angle phi is given by tan inverse XL minus XC by R, right? So here XC is 0, no capacitance is there, so only XL by R is the phase angle. So it will be simply, if you calculate, both of them will be same and they will cancel, you will get phase angle to be 45 degree. They will not give you a value where you actually require you sine cos table. All the values will be in the standard level only. Okay, next question. Consider the electron is revolving Consider an electron is revolving in a circular orbit in an uniform magnetic field B. Okay, with velocity v, the radius of the circular orbit is directly proportional to. So you know that the centripetal force mv square by r is equal to bqv, obviously from Lorentz force, and radius is proportional to v by b. So on the given option, after simplifying it, you need to check the given option. This can be different based on different questions. Sometimes it can be V by B, sometimes it can be M by Q. So you have to be careful, you have to simplify this. If you remember the formula, directly write the formula and then you see, okay, this depends on V by B. Okay. Question number 43. A bar magnet has a magnetic moment of 2000 ampere meter square. Okay, so magnetic moment is given by 2000 ampere meter square. The magnet is suspended in a magnetic field of 30 Newton per ampere per meter. The torque required to rotate the magnet. So what is the formula for torque acting on a magnetic field? The formula for torque acting in a magnetic field is given by mb sin theta. Very simple, same as electric field, P sin theta. Here it is mb sin theta. So if you apply m is given, b is given, theta is given, everything is given, just simplify, you will get 30 Newton per meter. Next, 2 point charges are 3 meter apart and their combined charge is 8 microcoulomb. Okay, the force of repulsion between them is 0.012 Newton charges are. Obviously very easy question. Q1 Q2 K Q1 Q2 by R square equals to given 0.012. Okay, Q1 plus Q2 is given as 8. Right, you take one of them, you simplify it, you will get a quadratic equation, and there is no shortcut as such. Okay, you have to simplify them as like this, and you will get a quadratic equation. And quadratic equation, after solving, once you reach here, you will see that so only 6 into 2 is possible. Okay, 6 and 2 are possible. 6 into 2 is 12, and minus 6 minus 2 is also 8. So 6 and 2 will be the answer. Okay, one more shortcut trick. What shortcut trick can you apply in this particular question? The shortcut trick that you can apply is basically very simple. Okay, you see that what is the value given here? 0.012. If you remove everything, you will get 12. The answer is 12. Now, which of the quantities is, when you multiply them, you are getting 12. When you add them, you are getting 8. Only one possible answer, that is 6 and 2. 6 and 2, when you are adding them, you are getting 8. When you are multiplying them, you are getting 12. So this is our shortcut, easy trick to answer such a long, difficult question. Okay, if you try to solve it in longer method, you will get this, but if you apply your brain, you can answer this easily. Next, 4 cells, each of EMF E and internal resistance small r are connected in series across an external resistance R. By mistake, one of the cell is connected in reverse, then the current in the external circuit is. Now this question I am giving you as a homework. The solution is given here, but I will not show you the solution. You can solve this question as homework and mention the answer in the comment. Okay, question number 45 as homework. You can mention the solution in the comment below. Okay. Now let's move on to question number 46. Which of the following are not electromagnetic waves? Cosmic rays, gamma rays, beta rays, X-rays. Cosmic rays are a mixture of electromagnetic and particle motion. Gamma rays are obviously part of electromagnetic spectrum. Beta rays are actually moving electrons. High speed electrons are called beta rays, which come out of the nucleus. X-rays are also electromagnetic radiation. So only beta rays are not electromagnetic radiation. Okay, cosmic ray is mixture of electromagnetic radiation and particles, which is basically coming from space. Anything which is coming from outer space is called cosmic rays. Potential of large liquid drop, when 8 liquid drops are combined, is 20 volt. Then the potential of each single drop, very simple. You calculate the volumes, okay, and radiuses. Okay, obviously from combining the radius, you can calculate that when 8, remember that it will be always be cube root of the number given. If it is 27, cube root of 27 is 3. Okay, so radius of the larger sphere is cube root of the number of spheres times its radius. Okay, remember this formula. This will be very, very handy. You don't need to do this mathematics always. If you remember that, here 8 is given, so cube root of 8 is 2. So radius of the larger sphere. So what happens here? We have small 8 spheres. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And once you combine them, they form a large sphere. So radius of individual spheres are small r, radius of the larger sphere is capital R. So always remember, radius of the larger sphere will be always cube root of the number of spheres into one of the radiuses. Okay. So now voltage of the smaller sphere, voltage of each of the smaller sphere is given by what? It is given by kq by small r. Okay, so if each of them have a say charge q, then the voltage of the sphere on the surface is kq by r. Now when you combine all of them, what is the total charge? Total charge will be 8q. Total charge will be 8q. So what is the potential of this? Potential of this one will be k into 8q. Don't forget this, 8q by r. Okay, so this is the total potential, and this is given. Okay, potential of the larger drop is given 20 volt. So 20 volt is given. Now you put the value. So 20 equals to 8kq by 2r. Okay, this capital R is equals to 2r. So this cancels. So you can calculate kq by r. So kq by r equals to 5 volt. Okay, so correct answer will be 5 volt. Okay, not difficult. Okay, if you think quietly, you should be able to solve these questions within the exam time. Two air capacitors 5 microfarad, 10 microfarad charged to 10 volt each are connected in parallel. The space between them, the first capacitor is filled with the material of dielectric constant 3. The potential difference across the capacitors becomes. So first of all, you need to calculate the common potential. Once you charge them and you charge them to same potential and connect them in parallel, the common potential will be same as the battery. You don't need to calculate that for the first part. Okay, you will get the same voltage as the source, so that is 10 volt. Okay, now when you insert a new dielectric medium between the plates, its capacitance increases by that times. Okay, so 3 dielectric constants, so capacitance will be 3 times. Okay, so first capacitor, so its capacitance will be 15 microfarad. Okay, 15 microfarad. So since the capacitance increases 3 times, the potential it becomes 1/3 of the previous potential, that is 10 by 3. So potential across that one will be 10 by 3. Okay, and then you can use the common potential formula CV1, C1V1 plus C2V2 by C1 plus C2. This is a shortcut formula to calculate. Otherwise, you have to calculate the charge, you have to calculate the equivalent capacitance and then solve it. So that will take some time, but this is a shortcut formula for common potential. Okay, first case you don't need to calculate it because both capacitors are charged using the same voltage, so both of them will have same voltage. Okay, and they are connected in parallel. Okay, so in parallel combination, this is the shortcut formula to calculate the common potential. Okay, C1 V1 into C2 V2 divided by C1 plus C2. Remember that formula. Current of 1 ampere is flowing along positive x-axis through a straight wire of length 0.5 meter placed in a region of magnetic field given by B equals to 2I plus 4J Tesla, the magnitude and the direction of the force experienced by the wire respectively. Obviously, what formula you have to use? F is equal to I L cross B, and I is given, L is given, magnetic field is given. So now because it's given in terms of I cap, J cap, K cap, you have to use the cross product formula and you can calculate F will be 2K cap Newton. Okay, slightly tricky but solvable. With practice you can solve it. Okay, this formula is obviously Bill sin theta. So remember, in case vector form is L cross B. Vector form is I L cross B. Okay, Bill sin theta we generally use BIL sin theta, but in vector form it will be I L cross B. Next, the internal resistance of the cell is 0.1 ohm and its EMF is 2 volt. When a current of 2 ampere is being drawn from it, the potential difference across the terminals will be. So obviously potential difference across the terminal can be calculated using simply V is equal to epsilon minus IR. Okay, so I is given, R is given, epsilon is given, everything is given. Just put the value, it will be 1.8 volt. Which of the following correct arrangement of the electromagnetic spectrum in the increasing order of frequency? So frequency is increasing. Okay, so which one? Obviously micro, infra, radio, visible, X-ray. Now out of all these rays, X-ray has the highest frequency. So X-ray will always be end. So either obviously first one is wrong. Okay, because radio waves are having the smallest frequency. So starting will be with radio waves and ending will be with the X-rays. So if you see that kind of thing is given, so radio X-ray, micro X-ray, obviously this is wrong, this is also wrong. So if you once you figure out what are all the ends of highest to lowest or lowest to highest, okay, here we are lowest to highest, okay, increasing order, that means frequency is increasing, right? So frequency increasing means highest frequency is X-ray given in the given formula, given list, okay, and smallest frequency is radio. So our starting point will be radio, ending point will be X-ray. If there are two unique matches, suppose this also have two such answers where radio and X-ray are starting and ending, then you have to check in between. But as you see in KCET, generally this much detailing is not there, okay. So radio waves and X-rays are at the end vertices, so you just need to check this and you can easily say this must be the correct answer. Okay, now let's move on. 4 charges equal to minus q are placed at the 4 corners of a square and the charge small q is placed at its center. If the system is in equilibrium, the value of q is. Okay, so this is a slightly tricky question. I think there should be a diagram. I think diagram is somehow missing. Okay, so let's see. What you have to do, you have to, slightly tricky question here. What is given here is, I think the diagram somehow got missing. We have a square minus q, minus q, minus q, and there is a central charge q. Okay, you have to calculate the forces. First of all, this charge is located at the center. Okay, so what are all the forces acting on it? The system is in equilibrium. That means q is in equilibrium. Just let me read the question. I think this question is slightly misleading, because the system is in equilibrium means, okay, this charge will always be in equilibrium. By the way, this charge will always be in equilibrium because net force acting at the center will be 0. Okay, so here it will be minus q in this direction, this will be in this direction. So net force at the center will be 0. So it does not associate themselves with the equilibrium of q, but you have to consider the equilibrium of a corner point, which is very, very important. Okay, so what are all the forces acting on this negative q charge? So first of all, there is a negative q, so this will try to repel in this direction. There is a negative force minus q, so it will try to repel in this direction. There is a minus q over here, so it will try to repel in this direction, and this q will try to attract it. Say this is positive charge, say this is a positive charge, so this will try to attract in this direction. So combining these three forces together and equate it with this force will give you the equilibrium. Okay, so if you calculate that everything, you will get the charge q will be q by 4, 2 root 2 plus 1. This is slightly tricky, difficult question, one of the difficult questions of this paper. Obviously, as you know, not all questions in KCET are super easy. Some of the questions will be difficult. Even if you skip this question, you have to answer at least 55 to 58 questions you can answer. Okay, that should be your target. You should not be thinking that, oh, I am not able to answer that question was difficult. Yes, that is part of the question paper. Do not think too much about difficult questions. You should focus mainly on the easier questions which are solvable, the questions that we are mainly solving. This question, for matter of fact, you can skip if you see a difficult question. Do not skip the questions which are actually easy but you feel it's difficult. Okay, for that you need practice. Once you are doing enough practice, you will realize, okay, which questions are difficult, which questions are easy. Two heating coils of resistance 10 ohm and 20 ohm are connected in parallel and connected to a battery of EMF 12 volt and internal resistance 1 ohm. Power consumed by them are in the ratio. So here we have a EMF 12 volt, R1 10 ohm, R2 20 ohm, internal resistance 1 ohm. So first of all, obviously you have to calculate the power. Power is given by V square by R. Now here obviously both of them are in parallel, that means voltage across them is same. Don't need to calculate the power. Okay, only thing you need to say is very simple. This will not require, you don't need to calculate the current. That's why I'm saying this question is not difficult. You don't even need to calculate the equivalent resistance. You don't need to calculate the current to calculate the power. Remember, they are in parallel, voltage must be same. So what formula we need to use? V square by R1, V square by R2. So this is the power dropped by this one, this is the power dropped by these two. Find the ratio. It is only the inverse ratio of the resistances. Okay, so it will be 2:1. Okay, so this is a trick question. So KCET is actually full of trick question, not super difficult or mathematically long questions. Yes, every year in physics there are 1 or 2 questions which are longer, but otherwise remaining 58-55 questions assume 5 questions are difficult. 55 questions are generally solvable easily. Those questions you should not miss. A current of 5 ampere is flowing at 220 volt in the primary coil of a transformer. If the voltage produced in the secondary coil is 2200 volt and 50% of the power is lost, then the current in the secondary will be obviously output by input, which is given Vs by Is by Vp into Ip. Everything is given. Okay, you can calculate the current in the circuit to be 0.25 ampere. Okay, so eta is the efficiency. Okay, eta is the efficiency. 50% efficient, it is mentioned, it is 50% efficient, so 0.5. Okay, 50% efficient means 0.5. Okay, output by input. Output power is secondary voltage, secondary current. Input power is primary voltage, primary current. Okay, so everything is given, and you can easily calculate the secondary voltage. Okay, you can complicate the things. This is the easiest shortcut way of solving this problem. An ammeter has a resistance of 0.1 ohm. It can read up to 5 ampere. To convert this into voltmeter to read 100 volt, the resistance to be used. Simple question, R equals to V minus Ig by G. We have learned this formula in our second PU lecture. Right from there you can calculate, it will be 19.9 ohm. Okay, now next. A current of 5 ampere is passing through a metallic wire of cross-sectional area 4 into 10 to the power of minus 6 meter square. If the density of the charge carriers in the wire is 5 into 10 to the power of 26 per meter cube, find the drift speed of the electron. Drift speed is I by NEA. I is given, NEA, everything is given. You can calculate the drift speed to be whatever value you will get. Okay, not difficult. In this diagram, potential difference between A and B is 60 volt. Potential difference across 6 microfarad capacitor is. So here potential difference between A and B is given. So here we have parallel combinations. So first step is to simplify that. Find the equivalent capacitance of the combination. Remember 3 CF were in parallel, so their equivalent will be 6 CF, and then you calculate the equivalent capacitance. Once you calculate the equivalent capacitance, you find the charge that is flowing in the circuit. Once you know the charge, you simply divide it by the given capacitor to calculate the voltage. Very simple, easy question. Okay, a 2 microfarad capacitor is charged to 100 volt and then its placed are connected by a wire. How much heat will be produced? So obviously it will be basically half CV square. C is given, V is given. No matter how you discharge the capacitor, you will always get the energy as half CV square, which is 0.01 joules. The unit of current element. Unit of current element is IDL. Okay, current element in Biot-Savart's law, current element is IDL. So its unit is ampere meter. DL is length, meter, I is current ampere, so it will be ampere meter. Now here the figure shows current in a part of the circuit, then what is the value of I? So here as you can see, let me show that clearly. Here we have a 2 ampere going in this direction. Here we have a 2 ampere going in this direction. Okay, and so what will be the total current over here? Total current must be 4 ampere, right? Now here we have 1 ampere current which is exiting in this direction. So what is this current over here? That means here we will have 3 ampere current. Now out of that 1.3 is exiting from here. So remaining 1.7 must be exiting from there. So current I is 1.7 ampere. Easy question. Just start applying Kirchhoff's laws and you will get the answer. Very simple. So we have solved all the 60 questions in this discussion today. If you have any more doubts, obviously mention in the comments. But if you are really interested in solving questions, more such questions, you should consider ABHYAS Test Series, and it is available right now only for a price of peanuts. Okay, you can purchase it from the link given in the description, and this will be very beneficial for all of you in your KCET preparation. Okay, see you in a future lecture. Till then, bye.